Hello everyone, I am Srinivas Nomula, a second year PhD student working with Professor Parimal Parag. I am here to discuss about my work, optimal pricing in multi-agent system. In the context of cloud computing, agents are the ones who provides services to their consumers with the vast servers they have and generate revenue from the services provided. So for our setup, we assume a system with n plus 1 servers where server 0 is solely maintained by a single agent and hence we call it a tagged server. And the other n servers are maintained by another agent, hence we call them untagged servers. The queue length of all the servers is unity. So here we represent it using a box describing the occupancy of the server. If it is idle, it's white in color, or if it is unoccupied, it's white, and if it's occupied, it will be red. Now, each agent can so here each agent can choose a specific distribution and all the servers which are assigned to that specific agent has to choose price from the client specific distribution. So when a job arrives with some arrival rate from a predefined distribution to the system here, while arriving it has its own value, say v1. Now when a job arrives, when this job arrives, the controller selects two out of the n plus 1 total servers at random, inquires the value of the job as well as the prices of the two selected servers. And if the value of this job exceeds both the prices, the operator selects the server with the minimum price and assigns the job to it if it is idle. So if the price of the server of only one server is less than the value of the given job, the system assigns the job to that server if it's idle. If that's not, if both are not satisfied, the job arrived is dropped, is not accepted. So at time zero, assuming that all the servers are free, we assign the job to some server or drop the job as discussed just now. So here we assume that server one has been selected and it has been processing the job until the next job arrives. So at the next arrival, this is how it looks like the system looks like. So now before discussing further, once the server is selected, the corresponding price is actually added as a revenue. And uh, our goal is to find the price rate of this tagged server under uh, this predefined conditions, which increases the limiting revenue. So hence, now let's see so as discussed, since the server one has been selected, it will remain full until the current job gets served. Now, when the next arrival happens, the operator again selects and assigns the job to the server as discussed earlier. And now these are our results where, in the graph, as you can see, Z star is the mean occupancy fraction, which implies that at a given arrival, we calculate uh, the number of, so the fraction of servers that are actually occupied, and we are plotting it here. And the at a given arrival, we also calculate the aggregate revenue of the tagged server, and we are plotting as follows. So through our calculations, we have actually found the the correct value of Z star, and we plotted it here. And the same with the server revenue as well. And as you can see, that the Z star, or the mean occupancy fraction, actually matches with the calculated, as well as the same holds true with the tagged server revenue as well. And you might be curious, why are we finding these things? Because we also derive saying that the optimal price rate is a function of this Z star, and so we calculate the optimal price rate from this Z star accordingly. Thank you.